Hello and welcome back to Compiler Programming. Today it is time for us to add some variable support. Shouldn't be too hard, but there is a lot of interesting stuff to discover, and most of it probably will happen later once we start thinking about optimizations and things like aliasing and stuff like this. But for now, I will do the dumbest thing possible, which is whenever we define a variable, we will just straight up create a location on the stack and assign it to that location. So whatever we are already doing in our macro code, this is exactly what's going to happen with Parsing as well. Okay, so should be able to define and look up an S64 variable on the stack. Okay, so we have our function foo, and that function foo will be void to S64, void to S64. Maybe we can call it checker, or it's fine. We'll leave it like this. And what else do we want? We also want to actually change this stuff. So what's going to happen is we will say x is going to be 42 and then return x. So this is just a convenience basically for defining and assigning. And if I want to just assign, I will do this. So I guess let's do, do I want to try to spread them out, or do I want to have this one? No, let's do this version right away. Okay, so we have x is 42 and x. That should be fine. We can try to build this. This doesn't accept any arguments, so something like this. We can run the test and see that it doesn't really work. Yeah, what it complains about is that it has no idea what to do with this expression, and that means that it cannot turn this into a single value that it can return. Okay, let's get back to our source and look for how we deal with constant definition. Now I can basically copy paste this stuff and change it to token rewrite definitions. It's going to be definition and assignment statements. Yep. And we can use it for our matching. So let's check what's happening. On the left side, we have an ID that seems pretty reasonable. On the right side, we have a value that is also good. It actually needs to have a little bit more things. So first of all, it needs to be probably this version of the rewrite. Let me grab this then and put it closer to here, because we're going to be dealing with the expression version, which is slightly different. So expression version accepts a function builder because it might need to actually emit some code or change some of the state of the function that we are currently dealing with. So this is like this. And as far as define lazy, we need to do one more thing before we do that. So the value that we get here is kind of an interesting thing. So technically, if we know that we have an immediate on the right side, we can literally just do exactly this, right? We could just say that whenever you look up something by this name, you would get a value. But this only works for immutable things. If it is mutable, then on the next line, I can do something like x is 7 or 4, whatever. And that means I will need to actually override it, and I would need to change it either in the register or stack location, wherever it is located. So for general case and the simple one without any optimizations, what needs to happen is I need to create a stack variable and use that stack variable and copy the value to that variable. Okay. For stack variable, I can look up how it looks like here. I think we have something like stack. Yep. So do I have version of the stack that is just without anything? I think I do, but I need to look at it in this file. So yeah. Honestly, I think I will do it without the macro for now, but macro can also work. It's fine. So we can say stack. We need to give it a name. It doesn't really matter. We can say that it's going to be a var, and then I think we need to provide a descriptor to it. Yeah, so that is value descriptor, and then we need to provide value. Yeah, that seems fine. In reality, I don't think we actually need the descriptor here. We could just do value descriptor, but I will not change it for now. That's okay. So now we defined the variable, and this variable is what we will use to define this as, and not in a global scope, but in a scope of the whatever is the current one. Okay, this is fine. I will leave it with this fix me. This is a separate change that needs to happen. That has to do with how statements are handled, which I will do at a different point in time. For now, though, we just need to actually use this stuff, and this is happening inside of this setup. So we do token, rewrite expression, state, token, rewrite definition, and assignment statements. That looks good. Reserve stack is not a member of token. Yeah. So here it is token value, and now I need to say value star value is token force value of token value, and token force value also needs a scope and a builder. Okay. Incompatible types from value star to token. Yeah, because here it actually is not a later definition. It is scope defined value, I think. Yep. And that should take care of what we need. But let's see if there are any other weird things that we have not anticipated. So I'll just get back to this stuff and let's run the tests again. Okay. So I have an error in the source one. Why is that happening? So what is the error here? slice equal error location file name is test file name. I will not dive into this because this is something completely different. I think this is actually a remnant of the refactoring that was done previously, so that's a separate topic altogether. But as far as variables goes, it seemed that at least the simple version is working just fine. Define, let's increase the complexity of the tests. Should be able to define, assign, and look up an Ep84 variable. So we'll assign it, start with 21, and we'll do assign to 42, and then we'll look it up. Okay, let's again run tests. We don't know what this equals, right? Our program does not know how to handle it. So let's just copy this stuff and do the same thing. And I think we could probably merge them somehow together, but it might be easier to actually just do it separately, because the only thing that happens is, the only common thing is this, and even that's not really common, so I don't think it's worth it to try to abstract this away, at least for now. We do need to force the value, but now instead of us defining something in scope, we actually have to look up. So we say value star target is scope lookup force scope. I don't remember what it takes as a parameter, so let's just look up how we're using it. Okay, it needs a name and a builder. That is fine. We can give all of that. So scope lookup force. Yeah, here we are. We need to give scope name. Name is name source and builder. Okay, and now we simply just move value. So actually do the real assignment of builder, I think, target, and value. I think I have a helper for this as well. Or maybe I don't. I think it is just move value. Function spec move. Yeah, I guess I don't really have the helper, but it's okay. Move value, we don't need to define this stuff, we don't need to redefine, and this should be it. Rewrite assignments. Okay. Let's plug this in. Rewrite assignments. Let's see if that works. And it does, which is really, really, really nice. So I think that whole framework that I now have with matching, obviously it has some corner cases that we'll probably discover sooner or later. But in general, I find it really, really nice and really easy how I can plug all of this stuff together, and how it should be possible later on to also allow users to define this stuff and in general make it much nicer. I think one final thing that I can try is to do something like this. Y is S64, or actually it probably needs to be S8. No, S64, S8. Let's keep that as 8. And then I will do Y is 10. Then X is 21. Then X is 32. And then X plus Y. Okay, and the idea here is that we also now need to support this version where we define something on stack, but we don't actually use it, or we use it in a separate thing. So actually here it's supposed to be like this. So let's create this version as well. And this would be token rewrite definitions. We now have this stuff. We yes, we do force the value. Actually, I think there is something like scope lookup type. Somewhere here we are dealing with types. So let me search for how we match arguments. Arguments, match call argument, match expression. This is also not what I want, and this is again not what I want. So this is call arguments. Program lookup type. Yes, this is what I was looking for. Program lookup type. I forgot to look at what it uses. So program and archetype name. Great. Program, we can get it from the builder. So we can say builder program. And then I can just do yeah, here we actually want an ID now. So this expects to have a type name there. This whole type name thing will also change later on, but for now this is what it is. Token source. Something like this, right? And we will need to actually do it ourselves because we just want to reserve stack, but we don't want to copy anything there. So that value is uninitialized. So builder and descriptor is value descriptor descriptor. I think that is how it goes. Or type descriptor. We'll see. And we define the value. Token is undefined. That's fine. We say type. Type source. Compatible from descriptor star. Okay, so it already returns a descriptor. That is very nice. Actually, I want to see what it does exactly because I don't remember. Okay, it returns already the descriptor of the type, which is great. So that means that we can do straight up like this and like this. Looks fine. Let's see if it works fine. Okay, I forgot to wire it into here, but that's okay. We can put it over here. Yep, and the problem here is that I don't have S8. But this problem is very easily solved. We just add it like this. I also don't have this stuff, but it is living inside of value, I think. No, I don't want to search here. Here. I can do value S8 and S8. Okay, let's try that again. And everything works just like magic. Cool, that was pretty smooth episode, but it is an important thing to have, which enables us to write much more complicated programs. I think that will be it for today. Thank you very much for watching, and hopefully see you next time.